This is the 16th question in your question bank. And in this question, they have given us a universal relation R that contains the attribute A, B, C, D, E, F, G, H, I, J. And they have given some functional dependency like A, B gives C, and from A I can derive D and E, from B I can derive F, and from F I can derive G and H, and from D I can derive I and J. And what they have said is what is the key of this relationship, as well as they have asked us to decompose this relation into second normal form and third normal form. Now, whenever you get this kind of question, first thing you have to do is you write the functional dependency one below the other. Even though it will take some time for you to write that thing, but it is better you write them one below the other. The reason for this is when you write it, you will come to know how many relationships are there. Carefully write down, don't miss out any of the relationship. And then first thing you must do is concentrate on the right hand side of the relationship and find out which among them here, which is there in the right hand side attribute, is not there in this relationship. So which here, you have given the universal set over here, find out which among them is not here in this relationship. Those which are not here are definitely are part of the key. So you will 100% they will be part of the key because none of them are able to derive those attributes. So let's start one after the other. So I'm going to start with the A we derived C. That means C can be derived. So check out C. It may be there, it need not be there, but definitely I can't say. But C is ruled out as of now because using A and B I can derive C. From A, I can derive D and E. That means on the right hand side, D and E are there. So check out D and E, they are gone. From B, I can derive F. So I will check out that. From F, I can derive G and H. So I'm going to check out these two. From D, I can derive I and J. So what is left over now is you notice that A and B are not derived by any of them. That means if you have to get the relationship, if you have to get the key, A and B will be part of that key. Along with the A and B, you may get to C, D, anything. But A and B are 100%, they are there. Others are not there. And we will start with the A and B itself, which is, we know that 100% they will be there. Let us try to find the closure for A and B. Now, we know that using A and B, I can derive A and B itself. For those who are not familiar with this one, so using A and B, I can always get A and B. So if you are wondering what is this, see, if suppose if I am given a telephone number, sorry, your mobile number, okay, I have the list of mobile numbers, so like this, okay, assume that I have the mobile number. Using this list, I can always get the mobile number. So using this list, you can always get the mobile number because it is the same list. So this is the same list. Using this, I can always get the mobile number. So in other words, you can derive yourself because you are the same person. So when I say A and B can always derive this. Using A and B, I can always get A and B. So they are part of the closure. Now let's look at the relationship. Then let's take the first relationship. AB derives C. That means if I know the value of A and B, I can get the value C. So add that thing, C, add that thing. So using A and B, I can get A and B. And also because AB can derive C, I can get that. Now let's look at the next one. Using A, I can always derive D and E. So if I know the value of A, I can get D and E. That means I'm going to add this D and E there. So using A and B, I can derive A, B, C, D, and E. Now let's look at the B. Using B, I can derive F. So add that to the closure. Now once I know F, using F, I can derive, see, using B, I can derive F. Using that F, I can derive G and H. So add that G and H to the relationship. Now using D, you know very well, using A, I can derive D. Okay. Using this D, I can derive I and H. So add them I and H to the relationship. So what you now have is you have A, B, C, D, I up to J and H. So that means to say that A and B can derive the R. So closure of A can derive. Now A alone cannot derive the whole thing, because you know very well, if you take A alone, you will not be able to get F. Okay? If you're not able to get this F, you will not be able to get G and H. So A alone can do it. Similarly, B alone, if you try to figure out why B alone cannot do it, using B, you will not be able to get D and E, because A is deriving D and E. So naturally, using B alone, you will not be able to get the other one, the entire relationship. Now, you can try any other thing. Now, you may say that, okay, I'm going to try with C and D. I will try to find the closure of C and D. Remember, C and D, even if you are without looking at here, using C and D, you will not be able to get A and B, because you know very well none of them are deriving A and B. A and B are not coming on the right hand side. That means A and B will be there as a part of the key. Apart from this A and B, you may have to add something extra to this, like C, D, or anything, to make it derive the entire relationship. Now, what we notice that A and B itself is sufficient to derive the whole relationship. So we'll take that A and B itself is the key for our relationship. Now let's go to the second part of it. And the second part of what they have said is decompose R into second normal form and the third normal form relationship. Now, before we venture into the second normal form, what is this second normal form? A relationship is in the second normal form if it is in the first normal form. Also, there is no partial dependence. So in the second normal form, there must not be any partial dependency. What is the meaning of saying partial dependency? Non-prime attribute, okay, should not depend on the proper subset of the key. So what is the key here? In our case, A and B are our key. Okay. So non-prime attribute. What are the non-prime attribute? All the other remaining apart from this AB, all the others are non-prime now, because they are not part of the candidate. Now, non-prime attributes should not depend on part of this key. So that is what they are saying. So in other words, the see what is a part of this. We have the relationship here. A and B is there. So we have A and B, which are key. Now using A, that is the partial part of the key. Using A, I should not be able to derive anything. So that is what they are saying. So using part of the key, I must not be able to derive the D, E, or anything. I must not be able to derive something. So in other words, in order to derive anything, both A and B are very much required. So using part of it, I should not be able to derive any non-prime key. But we notice that in our relationship, what they have given, there is a partial dependency. By partial dependency, you know very well the relationship that is given over here. Okay. A, which is the key now is for us, the key is AB. We are able to say that AB is our closure of AB is able to derive the whole R. So AB is our candidate key. Now you notice that the subset of this AB, that is A alone, can derive D and E, which is non-prime. Okay. Also, subset B, you look at the B here. B can derive F. Look at the story. So that means to say that part of this key are able to derive something. So when we say key, if you say there's something as a key, together they must derive everything. Not that one part will derive something, the other part will derive something. That should not happen. So if such a thing happens, it is not in the second normal form. So definitely this relationship what they have given is not in the second normal form. So what we notice here is A is able to derive a proper that is a proper subset. A is able to derive D and E, which are non-prime. Similarly, B is able to derive F, which is again a non-prime attribute. What is the solution for this? Solution is very obvious. You take them as a separate relationship. Take them as a separate relationship. take them as the separate relationship. So you had this universal set here, which consists of everything, A, B, C, D, E. You don't take this one as one relationship. So they have given this whole thing, A, B, C, D up to J, as one relationship. Now you break this relationship into smaller pieces. And how many pieces you are going to break? Definitely into three pieces. The first piece will contain A, B, D, and E. So because why? Because you know that the part of the key A is deriving D and E. So keep them as one relationship. Break it into one relationship. What about the second relationship? Part of the key is able to derive non-prime attributes, F. So keep them as one more set. What is remaining? So if you remove this D, E, and F, what is remaining? The remaining thing you write it. Definitely you have to write A and B, because you know very well, you already claimed that A and B are your key. So where is that thing gone? So I have already told you that A and B is your key. So A and B are required to derive the remaining part. So you break them into these pieces. So you say that the relationship is broken into three pieces, and together all of them are now all of them individual. This is not in the does not have the partial dependency. This does not have the partial dependency. This does not have the partial dependency. So this thing now, all the three are not in the are in the second normal form. Now let's go to the third normal form. So what is this third normal form? So relationship R is in the third normal form. If it is in the second normal form, that means there is no partial dependency, plus there is no transitive dependency. What is the meaning of saying transitive dependency? From A, I will be able to get B. I'm just giving you an example. Don't mix them with the AB here. I'm going to use the other one. From X, you are able to derive Y. Okay, from Y you are able to derive Z. So indirectly you are able to derive Z using X. So this is called as transitive. From X you go here, from then you go to the other one. So this is called as transitive dependency. So let's try to find whether there is a transitive dependency. Definitely these two relationships, that is the first relationship what we have here, that is this AB derives D. Remember, when you have one key and the thing, these are, there is no problem with this, there is no problem with this. There may be a problem with the last set, that is the R3. We may have to split R3. So let's look at the R3, because naturally there is only one key that is trying to derive the other. There is 1 and 1. When you have this 1 and 1, if you get this 1 and 1, you are the luckiest one. You will not be able to have any anomaly with them. If there is one key and one attribute, you are the luckiest one. Okay? And this must be key definitely. And because there is nothing, you don't have to do anything. It is in all the normal forms are satisfied by them. Problem comes only when you have two keys here like this, and then you are left with a few other things. Then you have to find the relationship. Now let's look at this relationship over here. Now you notice that A and B were your key, okay? But what you notice over here is F. If you look at this relationship, so F is able to derive G and H. D is able to derive I and J. So you notice here there is a huge story. So what do I mean by saying that is so use AB is our key. Using B, you are able to derive F. Using F, you are able to derive G and H. That means using B, sorry, not A. Using B, you derived F. Okay. Using F, you derive G and H. That means to say that B has a transitive dependency. So B goes to F, and F will decide the G and H. Look at this relationship, uh, the other relationship. If you know A and B are where the candidate using A. So look at here. Using A, I will be able to derive D. So I am able to derive D. Okay. Using D, I am able to derive I and H. So what is the meaning of it? A indirectly or transitively derives ing. So there is this transitive dependencies are there, or these two relationship, or which one ing and g and h can be transitively derived. So if at all you want it to be in the third normal form, you will have to break that thing. How can you break that thing? So this is what is written over here. Using F, I can derive G and H. Using D, I can derive I and J. So I can split this one. So split this. There is only problem with the R3. Split them and keep them separate. So using F, you can derive G and H. So keep them as one. Using D, you can derive I and J, keep them separate. So make them as a separate key values. And what is remaining? You take from this, you have taken G, H, I, J. What is remaining is A, B, C. Keep them as one more relationship. So how many totally relationships are there? So altogether, how many relationships are there? So first one is R1, A derives D and D. Second one, B derives F. Third one, F derives G and H. Separate relations. Altogether, 5 relationship. You keep them separate. All this together are in the third normal form. To summarize, the key of R is so the key of R is A and B, and second normal form you decompose the relationship with the into 3 parts, and in the third normal form you decompose again into 3 form. Now in the examination there is no need to write this summary. That's not required, but definitely put a box for this one to say that it is in the third normal form. Also put a box for this one, even though I'm going to just take it to the next line. So put a box for this one to say that it is in the second normal form. Also put a box for this, where is this, this AB is the candidate key, and that is the key. Okay, so AB is the minimal key, and say that A is the key of R. That's all you need to do. Thank you for your interest. We will meet again in the next.